Hello again. I would like to continue. This is the third part of basic algebra review. In the second part, we finished these two problems on factoring. So we're moving into rational operations with rational expressions. Rational expressions are expressions that consist of polynomials. So we are adding these three fractions. We are adding them, but if you notice, they don't have the same denominator. Okay, so before we do that, let's just look at this very easy example. Remember, if you have 1/2 plus 1/3 minus 1/4, the denominators are not the same. We've got to get the denominators to be the same. So we look for LCD. What is the smallest number that is divisible by 2, 3, and 4? That happens to be 12. So I wrote the 12, that's the lowest common denominator. So what do I multiply 2 by to get 12? That's 6, so 6 times 1 is 6. What do I multiply 3 by to get 12? That's 4, so 4 times 1 is 4. And what do I multiply 4 by to get 12? That's 3, 3 times 1 is 3. So these are called equivalent fractions. Now that the denominators are the same, I keep the same denominator, I combine the numerators. 6 plus 4 is 10, 10 minus 3 is 7. So we get 7 over 12 for combining these three fractions. So the approach is kind of similar. Excuse me, I had to have some water. The approach is kind of similar for these problems. All right, so let's look at the numbers first. The denominators are different, so we have to get the lowest common denominator. So between 5, 3, and 6, the lowest common denominator would be 30. So I'm going to put 30 here. Now, if you have variables, you always go with the variable that has the highest exponent. So you don't have an a, you have a to the third, you have a to the second. So my LCD should have an a to the third, always the highest exponent. Okay, and then I have a b to the first, no b, b to the second, so my LCD should have a b to the second. Sorry, got a little sloppy. All right, so then you say, what do I multiply 5b to get this denominator? So what do I multiply 5 to get 30? That would be 6. So I'm going to multiply the top by 6. There is no a cubed. I have an a cubed, so I got to multiply the top by a cubed as well. There is 1b. What do I multiply b to get b squared? That's 1b. Okay. I'm showing every little step. Now, next, what do I multiply 3 by to get 30? That would be a 10. Oh, sorry. That's 4 times 10. I put it in parentheses. And then what do I multiply a cubed to get a cubed? Nothing, it's just a 1, so forget about that. And I don't have a b squared, so what do I multiply 1 to get a b squared? It has to be a b squared. What do I multiply 6 by to get a 30? A 5. What do I multiply a squared to get an a cubed? 1a. What do I multiply b squared to get a b squared? A 1. So there you go. So then you simplify these, so you will get, I'm going to put it all over one fraction. Okay, so that's 12 a cubed b minus 40 b squared minus 5a. Now, are these like terms? No, there's nothing that makes them like terms. So that's it, we're done. It's a little funky looking fraction, but that's all there is to it. If there were like terms here, then you could have combined them. All right, let's move on to number 14. Now, when we're dealing with these, anytime you're looking for LCD, anytime you can factor any of the denominators, do that before getting the LCD. Now look at these guys. What's common between these two terms? Is there anything in common? Well, between 3 and 12, there is a 3, so I can take out a 3. I'm looking for GCF. And between x squared and x, There is 1x I can take out. So what's left? From 3x squared, I took out the 3x, so there's 1x. And 12 divided by 3 is 4. I had an x, I took out an x, so there's nothing left. And the other denominator is 6x. So what is the LCD? I'm going to write it over here. We'll look at it between 3 and 6. What's the LCD? 6. So I got to have a 6. I have an x here. And I have an x here, so I should have an x. And I have an x minus 4 here. I don't have it over here, so I should have an x minus 4. So that covers all my denominators. Now, you're not going to get that many problems like this. It's just, this is a review. So don't worry about it too much, but it's good to be exposed to them. Okay, so what do I multiply? Let me say it differently. What's in my LCD that's not here? Well, I got the x minus 4, I got the x, I got the x. I have a 6 and a 3, so what do I multiply 3 to get a 6? A 2. So I got to multiply the top by 2, so that gives me 6x. What is it over here? What do I have over here that I don't have over here? I got a 6x, I got a 6x. I have an x minus 4, I don't have an x minus 4, so that's missing. So I'm going to multiply the 1 by x minus 4. I'm going to get that. So my answer would be my LCD in the bottom. And then 6x plus x, that's 7x, and I can't do anything with a negative 4. And voila, there is my answer for combining those two fractions. I hope everybody's good. All right. Now on Tuesday's meeting, we will have time for question and answer if there is any of these problems that are not, there were confusions about some of the steps. We can discuss it then. All right, now, if you look at number 15, you see you got a fraction on top of a fraction. So that's called a complex fraction. When you have the numerator, denominator, or both of a fraction made up themselves of fractions, that's called complex fractions. Now, there are different ways of approaching this. I'm going to show you the easiest way. And the easiest way is as follows. Look at the GCF for all the denominators. You got, well, sorry, I shouldn't have circled around h. The h has a denominator of 1. So the denominators are 7 plus h, 7, and 1. So what's the lowest common denominator between all of these? That would be 7 times 7 plus h. That's your LCD. It covers 7 and it covers 7 plus h. Now that 1 is irrelevant. You don't have to worry about it. Okay, so I'm going to multiply the top and the bottom of this fraction by the LCD. This is just a technique. So basically, I'm multiplying top and bottom by the same thing, right? So I'm not changing anything because this over itself is 1. So I'm multiplying the fraction by 1. So I'm not changing anything. So when I multiply this by the bottom, this is on the top, nothing cancels out. So I just get, let me write it over here, 7 times h is 7h times 7 plus h. So that's the bottom. So let's just leave it like that. So 7 times h times that. Now, if I multiply this by the first fraction, this is what I have. I'm going to do it separately. I have 1 over 7 plus h times 7 over times 7 over h over 1. Since I'm multiplying, and this is on the top, and they're exactly the same term, I can cancel them. So what am I left with? This is a 1 here and 1 there. So 7 times 1 is 7 over 1. So that just gives me 7. Minus, now I'm going to multiply the second fraction by the LCD. I'm distributing here over 1. So what happens over here? Now the 7's cancel out. Again, I can cancel things out from top and bottom because I have multiplication between the fractions, and I have multiplication between the terms. If there was addition and subtraction, then I cannot cancel. So 7s are gone. I'm only left with 7 plus h. So I'm going to have 7 plus h. I hope everybody's with me. All right, the reason I put the minus sign is here because I have a binomial that is left. Okay, so there's a -1 there. So what am I going to do? I can't subtract these. Order of operations. My Aunt Sally, don't forget her for Christmas or Thanksgiving dinner. So, ha ha ha, bad joke. All right, so, so you distribute the -1. And you get 7 minus -1 times positive 7 is -7. -1 times positive h is -h. Okay? All right. Now what happens to these 7s? Boom, they cancel out. So I'm left with a -h over 7 times h, 7 plus h. Now, there's multiplication here. There's a -1 times h. What happens to the h's? Voila, they're gone. So I'm left with -1 all over 7 times 7 plus h. And you can just leave it like that. Or you can distribute the 7 inside. That doesn't matter. Are we good? This was a little challenging, I think, but that's okay. You guys can handle it. All right. Now, 16 and 17 require a little bit of a very short discussion about rational powers. And I uploaded this document on Moodle already. If you notice here, if your power or your exponent is in the form of a fraction, we call it a rational exponent, then you can write it like this or like this. Now notice this part, the denominator of your exponent became the root of your radical quantity. And this became a power. That's why we have this expression, power over the root. So if it's written as a fraction, your power, then the numerator becomes a power, the denominator becomes the root of your radical sign. That's why we have the picture of Hulk next to the tree. Hulk represents power over the root. Okay, so let's keep that in mind as we approach these guys. So let's look at 17 first. 17, you have let me write it again. I wrote on it, now I cannot read. Oh, 2, I thought it was 3. 2 over 3. First of all, that fractional exponent, the rational exponent, only belongs to x. It does not belong to -3. So it says change to radical form. So I'm going to write -3. Now what's my root? The root is the denominator of my power. So I'm going to write -3 times cube root. Remember, if the root is 3, we call it cube root. If the root is 2, we call it square root of x. And this is your power. The numerator becomes your power. And here's the radical form. Or you can write it like this. Either way is acceptable. Actually, I like the second way better. Or you can put the 2 on the outside, just like these guys. You see? Like that, or like that. So the bottom, the denominator represents the root of the radical. The numerator becomes the power. And that's it. You can either write it like this or write it like that. Now, number 16, it's other way around. It says change to rational exponent. So you see the root is 5. So, and 6 is outside. So 6 times x to the power of, what's my power? It's 2. What's my root? 5. And there you go. Oops, sorry, you couldn't see it. There you go. So power over the root. Power over the root. Remember that. Power over the root. That gives us a rational exponent. And always make sure your exponent is written higher than the base. So don't write it like this. X. It's not x times 2/5. You got to write it x to the power of 2/5. That means the exponent has to be written higher. All right. I'm going to skip number 18 because it's not necessary. But I'm going to show you another example instead, similar. Let's say I give you a problem that looks like this. Let me get out of there. I'll write it over here. Let's say I give you a problem that looks like this. 3 over x minus square root of 2. In mathematics, and in algebra in particular, we usually don't want to have radicals in the denominator. We want to get rid of it. So we carry out this process called rationalizing the denominator. Sometimes we can rationalize the numerator as well, but for now we do the rationalizing the denominator. So what we do is you multiply top and bottom by the opposite of the denominator. Now what is the opposite of the denominator? Everything is the same. You see x and square root of 2, except whatever the sign is in the middle, you switch it opposite. So if it's a minus, I put a plus. If this was a plus, I will put a minus. That's all. And then you multiply. So you have 3 like that. But for now, I'm going to keep the 3 on the outside. And maybe I will distribute at the end. So I'm multiplying the top. Now, for the bottom, I got to distribute. I got 2 binomials, 2 terms, 2 terms. So x times x, that's x squared. X times square root of 2, that's positive x square root of 2. So we finished distributing the x. Now we're going to distribute the negative square root of 2 times both of these. So negative square root of 2 times x, you get negative times a positive is negative x square root of 2. And then negative times a positive is negative. What's the square root of 2 times square root of 2? Well, it's square root of 4. Okay, so then look at what happens to these guys. They're exactly the same term, but opposite in sign. So they cancel each other. And what's the square root of 4? Everybody should know that. That's a 2. So I have this. And look, no more radicals in the denominator in opposition to the original problem. So we rationalized the denominator. We got rid of it. Okay? You might have 1 or 2 problems in your homework assignment that you got to carry out this operation. Let me give you one more example like this, and we're going to finish the basic review. What if I give you something like this? 4 over square root of 3. Just making that up. You're going to get rid of this. So you're going to multiply. Now, this is a little bit different than the previous problem, because previous problem you had an operation happening between the 2 terms. Here is just 1 term. So here I can multiply top and bottom by square root of 3. Why? You're going to see it in a second. So what happens on the top? I can multiply the 4 by 3 because 3 is under the radical sign. So I just get 4 square root of 3. In the bottom, what do I get? Square root of 9. And what is square root of 9? 3. So I get 4 square root of 3 over 3. Did I get rid of the radical in the denominator? Yes, I did. There's no more radical in the denominator. So that's called rationalizing the denominator, to get rid of the radical in the denominator. Okay, perfecto. The last 3 problems. Let's look at these equations that we are solving, such as number 19. So the best way to do this is move everything to one side. So I'm going to subtract 5x from both sides. Okay, so I'm going to, and are these like terms? No, because even though they both have x's, this is not x to the power of 2. That's x to the power of 1. So it's x squared minus 5x. And what happens to these guys? Boom, they're canceled. So you get 0. All right, everybody with me? Now, what's common to both of these terms? An x. So that's my greatest common factor. Remember in the last video we talked about that? So x, take it out, the GCF, and what's left? I had two x's, I took one out, so I'm left with one x. I had an x, I took out, there's no more x. So there you go. Now, if your equation is equal to 0 and you have multiplication between the terms, we apply this property from algebra called zero product property, which is which basically says you set each of the terms equal to 0. So I'm going to say x equals to 0 and then x minus 5 equals to 0. So because if this equals to 0, that means either x is 0, 0 times this is 0, or this whole thing is 0. So 0 times x is 0. So both of them could be 0. So that's why you set them equal to 0. So what does x equal to here? 0. So that's one solution. And then I'm just going to add 5 to both sides and solve the equation. So x 0 plus 5 is 5. So I'm going to have two solutions. One here, one there. So those are the solutions to this equation. We solved for x and we got two answers. Okay, and we get two answers because the degree of the equation is 2. So if the degree is 2, you can have maximum of two solutions. If the degree is 1, you can have one solution. If the degree is 3, you can have maximum of 3 solutions. You can have less, but the maximum is equivalent to your degree. All right, look at the degree is 2. So I'm going to have a maximum of 2 solutions. I can have less. All right, there are two ways of approaching this. You can take out the GCF first if there is one. So I'm going to show you both ways. So what is the GCF here? It's 3. So that's nothing. So I take out a 3. What's left? There was an x squared left. And what is 21 divided by 3? That's 7. Okay. Now what do I do with this 3? Obviously, I cannot distribute it back in because if I do, I get the same equation back. There's no point into that. If this is a multiplication, what is opposite of multiplication? Division. I can divide both sides by 3. Gone. What's 0 divided by anything? 0. So we get 0. And then I have x squared minus 7. Now, how do I solve that for x? Well, I can add 7 to both sides to get x by itself. 0 plus 7 is 7. And now I want to get rid of that square. So in order to get rid of the square, what do? I take the square root of both sides. That cancels each other out because I'm taking the square root. Now, why do they cancel each other out? Well, we go back to the power over the root thing. Remember that? Okay, if just let me show you very quickly. If I have this, what's my power? 2. What's my root? 2. So I can write it like that. What's 2 over 2? 1. So no more radicals. So that's why if you have a square, take the square root at the end in order to get rid of the square when you're solving an equation. So you get x. Now, anytime you're taking the square root at the end of solving an equation process, we always put plus or minus because both positive square root of 7 and negative square root of 7 is possible. So there you go. Those are your two solutions, positive square root of 7 and negative square root of 7. Let me show you one other way for solving the same equation. If you have this, you can also add 21 from get-go, like that. Cancels. 3x squared equals 0 plus 21 is 21. Then, since there's multiplication here, I do the opposite, division. And you see, it's the same thing. We get the same thing. So now I want to get rid of the square. I take the square root. X equals to plus or minus square root of 7. So either way, whatever way you're comfortable with, doesn't matter. We got to the last problem. Woohoo! Let's do 21. Okay, so since you have two of these, I would recommend you move the 20 to the left side. So you get this. That means subtract 20 from both sides. You get this. Okay, you have a polynomial that's equal to 0. So if you have polynomial equals to 0, one way of solving it is by factoring it. See if it's factorable. Okay, so we got x squared. How do we get x squared? We should have had x and x. So when you multiply, you get x squared. Remember that table of signs that I gave you in the last video? When we were doing problems 11 and 12, if you have two minuses, then you have a plus and a minus. Or minus and a plus, doesn't matter which order you put them. And then look at the the factors of 20. Okay, so what are the factors of 20? Let's list them. 20 times 1, that's one pair. 10 times 2, that's another pair. 5 times 4, that's another pair. I can't think of any other pairs. Now, look at these pairs and see which one of these pairs, when added or subtracted, the numbers, can give you a 1 in the middle, because we have a 1 in the middle. Now we can take care of the sign later. Can't be 20 minus 1 or 20 plus 1 is not going to give you 1. 10 minus 2 is 8. 10 plus 2 is 12. 5 minus 4 is a 1. There you go. So I can put a 5 here and a 4 there. But I need to test. So how do I test? I do the outer multiplication, negative 4x. I do the inner multiplication, positive 5x, and I combine. Do I get the negative 1x in the middle? I get positive 1x. So I got the 1, but the sign is not correct. So I am going to switch the signs. So that becomes a positive, that becomes a negative. So now I have negative 5x and positive 4x. That gives me negative 1x in the middle. So my factoring now is correct. Now what I still haven't solved for x. So what do I do next? Just like this problem. I have two quantities that are being multiplied that is equal to 0. So I set each factor equal to 0. That's based on zero product property. So I have x minus 5 equals to 0. And I have x plus 4 equals to 0. And then I solve each equation for x. I add 5 to both sides. Oops, sorry, that's not canceling here. 0 plus 5 is 5. Sorry, I didn't mean to do that. And then the x, so x equals to 5. That's one solution. And then I subtract 4 from both sides. And these guys cancel out, and I get x equals 0 minus 4, which is negative 4. And then voila, I got two solutions. So these are the two solutions for x in this equation. All right, everybody, we reached the end of our basic algebra review. We are done with this handout. I have uploaded it in the Moodle as well, so for you to look at. And then we will have some extra problems from the textbook, which will be your homework, the first homework of the first week, and then you will have a quiz on it. We'll discuss all of that during our first meeting on April 28th. Okay, see you guys then. Take care. Bye-bye.